Alright guys, welcome back. So in order to change the color of the triangle, we have to know that we're actually ignoring a bunch of things because we actually wanted to strive through the simplest possible situation to get a triangle draw out. We're ignoring troubleshooting, we're ignoring to handle exceptions, right? But what if this failed, right? We haven't done that yet. We'll have maybe one video to address that, but you know what to do, right? So you can do like a if, this thing because it returns an int, right? If that's false, right? If that returns for a negative value or something, then you would just see out and say, okay, this is wrong, or maybe we can even have a log library to talk about that. But that's just general programming practice, is not related to OpenGL in this case, and I believe that one also have to be tested. Anyway, actually this one. So yeah, let's not worry about those things yet. Let's just strive through the necessary steps to go on and change the color. Now, another thing we ignore is basically we're actually ignoring to specify a shader, okay, a shader to tell how to render the triangle. And the OpenGL version 4 will use like a default shader that's black, and that's why we're seeing a black triangle. So we need to really specify our shader now. Okay, so right away I'm gonna go ahead and create some shader files. Let me right click and add a new folder. Call this guy resources. Okay, and inside of the resources I'm gonna add a new folder. Call this one shaders. And instead of that, I'm gonna go ahead and add some atom. Okay, and this one will be called vertex shader dot shader. Okay, I'm gonna go ahead and do another atom, and this one will be called fragment shader dot shader. Okay, hit enter to do that. That's gonna create two files. They're having this extension dot shader. You can see the icon Visual Studio gave them, right? Looks really cool, like a material bar or something. So basically that's some shader files we can specify. So there are two primary shaders we deal with when we were doing graphics, 3D graphics, vertex shader and fragment shader. Okay, so vertex shader defines things and attributes about different vertices of a 3D model, right? Not only their location, but also their UVs and their normal direction, right? Or any other things you want to pass over, even arbitrary stuff, custom variables or attributes, right? And fragment shader will be the part that actually convert or read from the result of the vertex shader and utilize those informations to determine a pixel. The color of a pixel. So that's the one that's actually doing the final render, more or less, right? So we'll need those two separate parts to get it to work. Okay, so let's start with the vertex shader here. I want to go ahead and do a hash version here to define the version, which is core. Actually, I think it's 460 core, right? That's the version here we need to specify. Okay, it's basically the same thing we again used, we specified in GLAD, right? The GLAD version here we are using 4.6, which translated here is 460, right? And the core profile. Okay, and then shader are basically a small program we run on our graphic card, right? So that's actually a real piece of program, and it's using a language called GLSL for OpenGL, right? We need to specify the main function. So we're basically programming a new program that will run on the GPU, and that's why you're seeing the main function again, but it does return void in this case. Okay, so the first thing we need to specify is what do we get from the data we passed in earlier, and we can type in a layout, okay, and then location equals to 0. Okay, and then in vec3 a position, attribute position. Okay, what this means is if I drag the main function over here, right? So basically this means is that we're finding the data we passed in. That's at the first index. Okay, so basically this means we're trying to look for any attribute pointer that's have the index of 0. And that's the one we specified in this line specifically. Line 33 defines on location 0 or index 0. That is what basically reading what value you're using in here, right? So that's what. So we're reading basically 3 floats. So we read that 3 float and we pass it in and create a variable called vector3 a position, right? a vector3 variable that's named a position. Okay, and then here we can use that to pass out and say GL position will be equals to that. Actually, it will be needing to be a vector4. The reason for that is because it needs to be multiplied with matrices, and matrices actually need to be multiplied with a 4-dimensional vector to work. But that one is something you probably never need to change unless you need to do some tricks. Again, a placeholder variable, right? Just for you to be able to multiply with matrices easily, right? So that shader will allow us to basically read the position and use it. Okay, that's basically what the default behavior is for that default vertex shader. If we don't specify one, the black triangle, the shader that black triangle is using. Okay, now we're just rewriting it here and we'll be extending from here, of course, right? So that's the vertex shader. Okay, we don't do anything fancy in here. Fragment shader will be something similar. Hash version 460. You have to specify that first, not 406, 460. Again, we need to define the main function here. Okay. For fragment shader, we just need to do a alt vector4 final color maybe to output that. That will be read eventually by the system to be the color of our triangle. Basically, we can just say final color will be equals to, we can do just something ourselves real quick, hard-coded number like 1.0 for R, G will be 0.3, 0.5 maybe, and B is 0.3, and R file is 1.0. Right, that should be everything we need to do. Right, the simplest shader we can ever do, which is basically vertex shader just take care of the location. Fragment shader doesn't care anything but give the triangle a solid final color, which is this one. Okay, alrighty. So when that is done, then we need to read the shader and use them here in our OpenGL program. Okay, so in that case, we need to specify the shader here. Okay, so we're gonna go ahead and create our shader by doing a GL. Actually, actually, we need to read the shader first, right? There's still something just outside of our system. They're just different files. So we need to read the files. We need to use string for that purpose, and we probably need to use a file stream just to read files from C++. Okay, right? So here I'm gonna go create maybe a function that can do that. Okay, so a function that's void read source shaders read shader. Okay, and then we do std string reference alt source, and then const std string directory. Right, so we're basically, when we pass in the string, we'll be populating that string with whatever file that's in this directory. Okay, so after that, right, we need to go ahead and load that. So std in file stream, and then initialize that with our directory. Okay, right, and then we can also do a std string read, so we can temporarily store every line into this read. That way we can do a while std get line, and we're getting lines from oh, actually, I need to give this guy a name. Source file stream in file stream maybe. Okay, right, so we're basically getting line from source in file stream into read. Okay, right, getting that, and then we pass that or add that to the outsource. So outsource at plus will equals to read, and let's also plus equals to a new line. That will give us a new line also, right? And that should be it actually. So this will read any data, any strings, any lines, right, line by line into this out string we passed in. Let's test that. Okay, so I'm gonna do a std string vertex shader source string will be equals to actually do that, and then read shader, read that, and directory will be here, so we can just pass it in. Resources, and then shader, right? Shaders, and then vertex shader dot shader. Okay, alrighty, and then let's just do a cout and see what we have. So vertex shader string source, okay, and run this. Right, you can see indeed we're reading out every line in this file, right? There's a one-to-one match. That means we're reading the source file properly. Do the same thing here then. std string fragment shader source string. Do the same thing. Read shader, right? And this time we're reading it into fragment shader source string. And I think I can just copy that and change the naming into fragment shader. Fragment shader, right? And then we're also going to see out this guy just to test, right? Fragment shader source string, and run this. Right, we see both shaders printed out. That's nice. Now we have the shader written down, we have them printed out, and I guess we can start to use them, right? So we need to create actual shaders so that's also handled by using integers, right? So vertex shader equals to gl generate shader or create shader, okay, and we're type is going to be vertex shader, of course. Vertex, right? So, and then we need to do gl shader source, and this is going to be yeah, we need to pass in the vertex shader also, right? The shader, we need to specify the source, we need to specify one source, and this one requires a constant gl char pointer, constant pointer string, right? gl char, if you look at it, it's a hash defined, oh, it's not a hash defined, it's a type defined char. So basically it's a char, right? So basically what that variable is, char pointer and then pointer. Basically that's what that type actually has to be a constant, right? If you hover the cursor here and take a look, and that's basically what that is if you replace that with, you know, char. So constant, char pointer, constant, right? Two constant, but you know, basically that's what that is. What we have to do here is to create a constant char pointer first, and make it equals to our C string from our source string. Okay, so vertex shader source, I'm gonna say raw will be equals to vertex shader, vertex shader source string. I don't know why that doesn't go through. Try that. Yeah, I'm missing a R. And do that. Okay, and dot C string, right? That's gonna give us the string, and then get us the char pointer here, so we can use it, right? So we have a char pointer, we just need to tap in the address of that to basically achieve a variable that's of the type constant char pointer, right? So yeah, and then basically some type pounding, get it to be converted. And then the length, right? How far do we read in the file? We can type in a null pointer to tell it to read as far as you can read, so read the whole file basically, right? And then gl compile shader is needed to actually compile after we load the source file. Okay, and then that should be it. So we'll do the same thing for the fragment shader, right? Constant char pointer, fragment shader source raw will be equals to fragment shader source dot C string. Okay, and then unsend int frag shader will be equals to gl create shader, right? And we're gonna create a gl fragment shader basically, right? And then GL shader source again, and this time we're gonna give the fragment shader the source, which is again the address of fragment shader source row, and then null pointer for it to read the whole thing. Actually, we need to have another number one here to specify we have only one source file. Okay, alrighty. And then we need to compile the shader as well. So compile shader, and we're compiling our fragment shader. Right, that's gonna be the shader reading and then compiling. Now eventually those two shaders has to be linked together into a program. Okay, so GL generate or create program. Okay, and then that's all we need to do. So yeah, actually we need to give it a variable. So yang3 int program v equals to that, right? And then GL attach shader. We're attaching our vertex shader to our program. We're attaching the fragment shader also to our program, right? Fragment shader, program. Okay, and then GL link program. We're linking our program, right? And then eventually, if everything goes well, right, GL use program to use our program basically. Right, and eventually when we're done with all those attaching, the shaders can actually already be deleted. So we can do a GL delete shader. Shader. Right, when we're deleting our shader here, that's going to be our vertex shader and our fragment shader. Right, so basically that's all there is for the shader reading. We create a function for that. And this is basically repetitive, right? For both vertex and fragment shader, you do the same thing, and you create a program, you attach the shaders, link the program, use the program, and get rid of the shaders. Okay, alrighty, let's go ahead and run this code. Right, I'm still getting a triangle, so there might be some errors in my code that I need to check. Okay, all right, let me see. It's hard to tell, so one thing I can do is to get those things printed out. You know what, this is 17 minutes, that's getting too long, so maybe next time, right, we start to adding a few more debugging system to this so we can see what's going on. All right, yeah, let's do that in the next time.